Hello world! Welcome back to another picoGym workout exercise video. In this video, we'll be walking through the binary exploitation challenge, Pi Time. Let's get into it. Can you try to get the flag? Beware, we have PIE. Connect to the program with Netcat, and they give us a Netcat portal to connect to. The program source code can be downloaded here. The binary can be downloaded here. All right, let's go ahead and connect to the Netcat server here and see what we're dealing with. Address of main, and then they give us an address. Enter the address to jump to. We don't know yet without investigating the binary and the source code what that address will be, so we'll just type in something random here. Your input 1337, seg fault occurred, incorrect address. All right, let's go ahead and take a look at the source code. We can see that there's a win function right here. There's that seg fault error handler right there. And if this win function is triggered, it'll print out you won, and it's going to open up the flag.txt file in the file system on their server, and it's going to print it out to the screen for us. If we scroll down, we can see the main function, and we can see that that's where it's prompting us with the address of the main function, as well as prompting us for the address that we need to put in, which will more than likely be the address of this win function right here. We want to try to call that win function. So that being the case, we can go back to our Kali VM here. And as you'll see, I have the binary here so we can test it locally. So what we're going to do is we're just going to do obj dump tech d on our binary, and we're going to grep for the win function. As you can see, this address looks a lot different from this address. And even if we run it on main, it's going to look significantly different as well. So right here, this is a lot different from this. What that means is this is probably being populated upon execution of the program somewhere. So what we can do is we can actually run GDB on our binary, run it, put whatever we want to in here, doesn't matter. Then we can run disassemble on main. And as you can see, this looks a lot closer to what's shown here. However, it's still different. And the reason is because however they're computing the main address on their end is fundamentally different from how we're doing it locally. But all hope is not lost because we can determine where the win function is. And all we need to do is figure out the offset between the main and the win function, because this binary is implemented in such a way that the distance between main and win will not change regardless of where you're running it. So if we figure out the offset between main and win in our local binary, we can pretty much subtract whatever that offset is from the main address up here, or whatever it gives us when we run it, and that'll give us the address for our win function. So that being said, let's go ahead and open up a new terminal window, and we'll zoom in a little bit there. Now we're going to take the address of main. So we'll grab this, and we'll open up Python, and we'll paste that in, and we'll subtract the address of win, which I think I need to print that out. Yep. So we'll do disassemble win. We'll grab that address, paste that in. We see that our offset is 150. And we can confirm that that is the case by just simply taking our main function's address, subtracting 150 from it, and we should get the address of our win function, but we need to convert it to hex, of course. So let's do that. And there you go. This matches this. The preceding zeros can be taken out. Those don't matter. So now that we've confirmed the offset, all we need to do is run the original netcat. So let's quit out of GDB here. And we'll rerun our Netcat portal. We're going to take the address of main, and we're going to subtract 150 from it. And that should be the address of our win function on the back end. So we'll copy that, paste it in, press enter, and there we go, we won. Our flag ends up being basic position independence. So we'll copy that, paste it in, and submit. All right, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.